So in the event you're having to watch this lesson from home, we're going to take a look at solving combination circuits. And so I'm going to flip this thing over to this, and I'm hoping that all of you that are along with me, you've sharpened your pencils because we're going to go through and try to analyze this. When I say analyze a circuit like this, what I'm saying is determine how much current flows through each light bulb, how much voltage drop is across each light bulb or each resistor. So first thing I'm going to do is I'm going to draw a little model of this. Raise your hand, you like to ski downhill? A few people. I'm gonna think of this 15-volt battery as a ski lift, and I'm going to ask you to draw this along with me. So I'm just doing a little model, right? So this is a 15-volt ski lift. It's lifting up those charges up to a certain potential. Now, as the charges flow through this portion of the wire, there's no voltage drop. We're saying that that wire has zero resistance, even though it has a little bit. We're going to say that it's that everything up here is at the same potential, 15 volts. Now, it's going to have to take a drop in potential as I go through this first resistor that's labeled R1. When I think of that as a voltage drop, it's like going down the hill a certain amount. Now, it's not going to go all the way down the hill because we still have other paths to go down through. So if I'm a skier, I get down to this point, I'm at the base of this next hill. That portion right there is essentially this part of the circuit. Now, I see that there's actually two paths that I could go down. I could go down the more convoluted, tortuous path, which is a 60 ohm resistor. That's maybe the one with the mogos on it and stuff like that. But I could also go down another path that is easier to go down because it's only a 30 ohm resistance. And when I'm done, I get all the way back down to the bottom of the hill. Now, if I think of this as a 15-volt hill, there is some voltage here that I want to determine. That voltage is whatever the potential is at that spot. I don't know what that is, but I'm going to try to find it. And then finally, I get all the way down to the 0-volt potential. So 0 volts is going to be lifted back up to 15 volts with that battery. Now, are you guys in agreement here that whatever the current is in here, if I think of this as a current or a flow rate, this would be technically inside the battery. Would you agree that that is the current that flows through R1? Would you agree that that current has to flow through R1? There's no other paths for that. So whatever this current is, if I call that I of the battery, that's the current that flows through R1. Now, it goes through some delta V. Delta V1 is something I'm going to try to find. So it's how much of a drop does it experience? Once I get to that point, I see that there's two paths for it to go down through. Well, these two paths are going to give the exact same voltage drop. It's going to be delta V across 2 or delta V across 3. They are on the same point of the hill. They're just two different paths. Let's look at this from a current standpoint. Would you agree that I1 here, the current through I1, has to split up? Some of it's going to go through this path. Let's call that I2. And some of that's going to flow through this path. We'll call that I3. You guys in agreement that whatever I1 is, I2 and I3 have to add to that? This model is just to help you sort of understand how charges are sort of flowing through that. Our goal is to figure out what those flow rates are and what those voltage drops are. That's what I mean by analyze the circuit. Now, Colton, I looked at yours really quickly. I think you did that right. Okay, you can take any kind of circuit, no matter how complicated, and sort of work through this to figure those things out. What I'm going to show you, again, the reason why you need a lot of space is I'm going to take this circuit and I'm going to break it into simpler circuits as I go through here. Go ahead, Kevin.
How can the delta V of 2 equals delta V of 3 if the resistance isn't the same?
But look at it. If I think of this as I take a voltmeter and put it across this resistor, wouldn't that be at the same potential as, isn't this side of that resistor at the same potential as this side of that resistor? They're connected together, right?
Yeah.
Same thing down here, they're connected together. So if I think of that as a voltage drop or a height of the hill, these things have to be going from some potential, which I don't know what it is yet, but they got to go down to 0 because they're all connected together there. So they have different currents because they have different paths, but they have the same voltage drop. Again, things that are in parallel have the same delta V because they're connected across each other. Things that are in series have the same current. Go ahead.
Wait, so then what does the difference in resistance do anything to
Yeah.
it?
Yeah, when I get to this point, well, why don't you turn and tell that person that you're sitting next to, how would the current in the 2 ohm or in R2 compare to the current in R3? Just turn and tell that person that you're sitting next to. How would those two currents compare? They won't be the same. How should their currents compare? One should be twice as much. The one that should be twice as much is a 30 ohm because it's half the resistance. So if I is V over R, if I have a less restrictive path, then more of the current's going to flow that way. So we're going to calculate those values, but in a parallel arrangement, they share the voltage, but they have different currents depending on what the resistance is. All right. So what I'm going to do is I'm going to show you how to analyze this. And again, what I would suggest that you do is redraw this first one exactly the way that it is. So I'm just going to redraw it, and I'm going to do some things with this as I move through this kind of analysis. So all that is a redraw. I'm going to call this R1. This here is R2. This here is R3. I'm going to move from left to right, and I'm going to simplify that circuit. So the first thing what I'm going to do is I'm going to combine these two resistors. I see that these two resistors are in parallel with each other. So I'm just going to think of this as an equivalent circuit that has R1 in series with R2 that was in parallel with R3. So I'm going to write this as R1. This here is R2 parallel with R3. And I think for this one, I'm going to go ahead and I'm going to compute that. If this were 30 and this were 60, some of you got pretty good at this. What's the equivalent resistance of 30 in parallel with 60? 1 over 30 plus 1 over 60, take the reciprocal of that. You guys agree that's 20?
60 divided by 3.
60 divided by 3. I'm not sure how you got that, but
Well, it's 1 over
when they're the same resistor values, I might take the 60 divided by the number of resistors in there. But anyway, another way you could do this is something called the product over the sums. When I have 2,
I said the same thing as you.
60 divided by 3 will get me there.
Yeah, no, 1 over 30 plus 1 over 60.
Oh, I got
3
you.
over
Yeah,
60.
that's fine. You're okay. There's no problem. I'll take it. 60 over 3. You are correct. That'd be 20. Anyway, this is 20 ohms. Now, this is still 10 ohms. I'm going to do one more, and I'm just going to make this be as simple as possible. I'm going to think of this as a single battery with a single resistance. Now, again, some of this is going to be more than you need to write, because as you go through this, you'll be like, oh, I got this. I don't have to do all these things. All I'm doing is I'm breaking this down into a single battery that's 15 volts of potential and a single resistance, which is the sum of R1 plus R2 in parallel with R3. Now, would you guys agree that this number over here is 30 ohms? This is 10. This is 20. This is 30 ohms. This is a 15-volt battery. Now, if I want to determine I from the battery, I'm going to take delta V of the battery and divide that by the equivalent resistance of that circuit. So delta V of that battery is 15 volts. The equivalent resistance is 30 ohms. I've got that the I of the battery is 0.5 amperes. That's equal to I of the battery. That happens to be equal to I1. That's the current flowing through that first resistor. Colton, did you have that? Okay. I've got the current flowing from the battery, and all of that flows through the first resistor. Now, my next step is I'm going to take this and I'm going to work this way now. I'm going to start working this way through this analysis. I know that current. So what I'm going to do now is I'm going to take that current over here and I'm going to try to determine the voltage drops across these things. So that's the I going through the battery. That current flows through the R1 value and it flows through the parallel combination of R2 and R3. So one thing I can do from this is I can calculate delta V1. I want to determine how much voltage drop I have across that resistor. I take the current flowing through it, multiplied by its resistance value, and I get then the voltage drop across that. So what is that, half an amp? Multiplied by resistance of 10 ohms, I've got that to be a 5-volt drop. What that means is that this hill had a height of 5 volts. So if this was at 15, this must be at 10 volts. So that I had a 5-volt drop across that. Can I determine delta V2?
Wouldn't it be 10?
It should. It should be 10 because again, you have all sorts of ways to be able to look at this, but I'm at that part of the hill, I got to go all the way down to 0. This has to be the same voltage drop as that. If you're not sure it's going to be 10, let's go ahead and just calculate it. What is the current? Delta V2 must be the same as delta V3. And how could I find that? I would just say the current from the battery, which all of that current from the battery actually flows through that parallel combination. So I might say, well, it's I from that battery multiplied by the equivalent resistance of that. And what Kevin said is it's going to be 10 volts, and you're right, it is. 0.5 amps multiplied by 20 ohms, which is the equivalent there, gives me 10 volts. And you already sort of predicted that. Okay, so now what I know is delta V2 and delta V3. So I've got all the voltages determined. The only thing left for me to determine is the amount of current flowing through those two pathways. So I'm going to do one more. I'm going to now look at it over here. So the way that I'm doing this, at least I'm trying to show you this in some way of an organized fashion, is to break the circuit down into simpler components and then sort of work backwards through this to determine how much current and voltage is across each device. Now at this point over here, I've already determined delta V, I've determined I1, I've determined delta V2, delta V3, I've got delta V1. I'm going to circle this, so a good worked out solution has the answers circled. So everything that has a pertinent answer is circled for me. Finally, I need to determine how much current flows through these things here. So I2 is equal to delta V2 divided by R2. Delta V is 10 volts. The resistance is 30 ohms. When I go through and do that, I get 0.33 amps.
Wouldn't it be 20 ohms?
Now I'm at this spot, Kevin.
Oh.
So now what I'm doing is I'm determining how much of that current flows that way, how much of that current flows this way. Okay? So 10 volts across 30 ohms means that 0.33 amps goes through that. That's I2. And if I want to determine I3 has the exact same voltage drop, but it has a different resistance, R3. That would be 10 volts across 60 ohms. And that gives me 0.167 amps. And that's how I'd go through and determine the current through each of those devices. Okay? Now, this is about as simple of a compound circuit as we can make. It's got a combination of parallel circuit in series with a series resistor. So this is about as simple as we can get. And you can see even with that, we had somewhat of a complicated path to be able to get through it. Now, I want to do one more with you, and then ultimately, I want to make sure you guys have some time to be able to analyze some of these circuits. Have you guys looked at the next page in your practice set? The next page in your practice set has a whole bunch of combination circuits. So my goal here is to show you a couple of these things, and then give you guys some time to work through it. What are you looking at there, Becca? What's wrong? Did you just come to the real? Is that what you're like, oh my gosh? Okay, if you look at the next set of problems in here, there's a lot of, there can be some very complex circuits. Now I'm going to, Becca, did I give you all of the series homework problems? No. Did I give you all of the parallel homework problems? I'm going to give you all of, no, I'm not going to give you all of the complex circuits. Okay. They can be quite complicated. Becca, I'll tell you what, I'll allow you to choose which ones we're going to do. And then after you choose, I'm going to tell you the other ones that you have to do. Okay.
0. Do it now.
No. All right, let's try this one. Have you sharpened your pencil yet? This one's even more involved. You notice that I've got, I've got 5 resistors now instead of 3, and I have some alternate pathways. Will you draw for me the something that looks like a ski lift kind of thing? Just try it. I want to see if you're able to do it. It's not really part of the solution, but I think it does help kids early on to try to visualize what's happening with those charges and what paths they go through. So just take a moment, see if you can draw the equivalent of this for this circuit. Do that here. Just do what you can. Now, whatever you do, don't go below this portion, because right there, below this is where I have to do the solution, okay? So just try it. Okay, if you're watching this from home, you should be doing the exact same thing in your note packet, and then hopefully then we'll be able to go through and do the analysis. Colton, did you actually do this one as well?
Yeah.
You did? You just did it? Colton needs, I'm going to tell you what Colton needs. Colton needs to solve this one. Colton needs to.
I think I got it.
You know what?
This one.
Good.
Okay.
I'll do it.
You might actually do this one. When Becca's going to
How is he
choose.
going to enjoy it?
Becca's going to choose. I'm either going to have us do 9, 10, or 11, and I think Becca's probably going to choose 10.
I think the problem is I just visualize it. Like, my mind just works.
I know. So the hard part for you might be communicating how you're getting.
Oh, yeah.
That might be. All right.
I
I'm going to sharpen my pencil again.
perfect.
You are trying to draw the map for me, if you will.
I actually have a sick mat, Mr. Heisinger.
May I show it? May I show it? May I show it?
Yeah, right.
He said he's not feeling too well when he did this. He said it was sick or something like that. I'm not sure. All right. So let's see. This is Mike. Mike. Can I say your last name?
Sure.
Okay. On record, Michael. What's your last name?
Dodge.
Has drawn this. So he's got a 120 volt lift here. Goes across R1. R1 now has 2 paths to get down to R5. One path is going to go through. Did you look at my answer key or something like that?
No.
This is exactly what I had. This looks really good. So one pathway, which is going through R2, takes us across here, and then the other one has 2 resistors for us to go through. This looks great, right? This is exactly the idea. So now, well, actually, I probably would have
It's not drawn to scale,
not to scale. I probably would have given a little one of these up here just to say we have a like this portion is right here, but that's okay. I like it. That looks good. So that map is not essential when you go through to do that drawing, but it does help visualize that a little bit. Okay. So thank you for showing that. And Mike, actually, here's the one that I had when I was doing this prior to class year. Is exactly the same kind of thing. Okay. So you have some R value. I have this R1. That's R2. That's R3. That's R4. That's R5. Now again, not essential. But this does help you understand how current, sometimes people get confused by how current. Would you guys agree that all the current from the battery must flow through R1? All the current through that battery has to flow through R5. But of course, some of the current is going to be going through there, and then the other amount of current is going to be flowing through here. And so all this is really doing is a visual for you to sort of help you understand how that current is flowing. Okay? This is more of a mechanical representation versus the electrical. All right, so here we go. Nice job with that. Let's go ahead and analyze this circuit. So what I'm going to do is I'm going to redraw the original circuit. This is so that I can use this if I need to. as I go through to determine the voltages and currents across each one of these things. So again, this is just a redrawing. R1, R2, R3, R4, and R5. First thing I would do, I like to work from right to left. You don't have to do that, but do you recognize R3 is in series with R4?
Yes.
So let's go ahead and redraw that. I'm going to draw that now. Looks something like this. Can you tell me what R3 plus R4 is? I mean, if I know, I'm going to put this right in here. What is R3 plus R4? It's just 20 ohms. Because those are in series with each other, I add them up and I get 20. Now this is still, is this 60? I know you guys can't see that really well. That's 60 ohms. This is 20. And this is 25. Okay, let's break that down to another one. Would you agree that these two in parallel with each other, so this group can be thought of as two parallel resistors? Let's go ahead and redraw it like so. Where this is R1, that's still 25 ohms. This is R5, that's still 20 ohms. What is the parallel connection of R2 in parallel with R3 plus R4? What is that value? So you notice what I'm doing is I'm putting those things in parallel. That's 60 and 20. So 1 over 60 plus 1 over 20, add those together. I believe it's 15. It is 15. Okay. So this is an equivalent resistance of 15 ohms. This is still 20. This is still 25. Now, at this point, you might say, well, I don't need to draw this last one, but I'm going to just to show you that every circuit, no matter how complicated, can be thought of as a single resistance value, which is R equivalent. And that single resistance value determines the current from the source. So what is that value? I just add these together, right? 20 plus 15 plus 25, is that 60? 60 ohms, okay. So that is 60 ohms of resistance. And this is 120 volts. So what is the current from the battery? It's 120 volts divided by 60 ohms, and I get 2 amperes of current.
Wow.
So I battery is equal to 2 amperes. That's also equal to I1, and that's equal to I5. I know 3 currents through that circuit. One is from the battery, one is through the first resistor, one is through the fifth resistor. And I know that because either looking at this up here, I see all of that current flows, or I look at it from over here. Doesn't matter. We okay with that? Okay, next thing. Now, what I have to do is I have to sort of work this way. So I'm trying to do this in some sort of organized fashion. I know the current flowing through I1. Can I determine delta V across 1? Can I determine delta V across 5? I sure can, right? So let's go ahead and do that. Delta V across 1 is the current flowing through that multiplied by its resistance. Now I need a sharp pencil here because I have a lot of writing. I apologize for that. That's 2 amperes flowing through that resistance. That resistance is 25 ohms. That's a 50 volt drop. I'm going to circle that because that's an important number for me. Easily seen then when I go through to look at your work, like, oh yeah, it's 50 delta V. If I come up here, this is what 120 volts of potential. Can you see that that's going to put this at 70 volts of potential? I have a delta V there of 50 volts, so sure enough, that height should be at 70 volts. Okay. Can I determine delta V5? The exact same amount of current flowing through it, just different resistance. So if I take 2 amps multiplied by, what was that, 20 ohms? That would be a 40 volt drop across that. If I go back up here, this potential must be at 40 volts because this potential is at 0. Can you determine delta V across these two things? Can you do that just from the diagram? This is at 70, that's at 40. Doesn't this have to be 30 volts across there?
Yeah.
Okay, I can determine that either by that diagram, or I could come up here and say, well, what is delta V2? Delta V2 is the same as delta V 3-4. Do you guys agree that that's the current that's flowing through this set of arrangements? Would you guys agree? So that would be the current flowing from the battery multiplied by that equivalent resistance of 15 ohms. For that, I get 2 multiplied by 15, and I get 30 volts. Questions over there, guys? I'll stop if we need to talk.
How come you don't use the 60 ohms again from like one for delta V2?
So delta, so up here, so I'm doing it across the equivalent resistance from here to there. What I don't know is I don't know the current through there. What I know is the current through this portion, but I don't yet know the current through here. So what I'm doing is I'm going to sort of go back to that particular point. Now, some people are probably going to find this to be, it's just easier to determine 30 volts based on this up here, right? Some people are just going to look at that and say, well, it's 30 volts because it's 70 down to 40. This has to be a 30 volt drop. Okay? All right, I have one more thing. I need to determine the currents through those. So again, every time I go to do this, I'm going to have to work backwards to more simplified circuits or more complex circuits. Go ahead.
Don't you want to find the volt change for R2 or R3 and R4?
Yeah. So what Mike just asked is, don't I want to determine delta V across here? I'm going to do that in this particular area.
Okay.
So let's go ahead and determine now. I know delta V2 and I know delta V3. Delta V2 and delta V3-4. I'm going to go ahead and determine. Sorry, give me 1 second. This right here is 3-4. Because what I know here when I go to do this one is I don't know the voltage drop across 3 or 4. I know the voltage drop across 3 and 4.
Yeah.
That's 30 volts. Okay. Now I still want to determine the currents through there. So let's go ahead and determine I. 2. And I want to determine I 3-4. So I going through 2 is delta V across 2 divided by its resistance. Delta V2 is 30 volts. R2 is 60 ohms. So if I have 30 volts across that 60 ohms, that would be 0.5 amperes. So the current flowing through that portion is half an amp. Well, coming into this was 2 amps, so coming out of this should be 1.5. Right? That current here should be 1.5. How I can do that That's 30 volts across 20 ohms of resistance, and that gives me 1.5 amps. So the current flowing through that series combination is 1.5 amps. Now the last thing for me to do is determine the voltage drops across 3 and the voltage drops across 4. I'm going to go ahead and circle this. I'm going to circle those. If I want to get delta V3, it's going to be I3 multiplied by R3. That current is 1.5 amps. That resistance is 5 ohms. I multiply those together, I get 7.5 volts. That's delta V3. And delta V4 should be the same amount of current that's flowing through there, but it's got a different resistance. And I ran out of space there to be able to fully write that. But that'd be 22.5 volts. Okay? Again, a lot of writing. When I went through and I'm like, oh my gosh, I got to show these kids how to do this, I probably should have given you more space. And I apologize for that. But when I say analyze the circuit, what I'm talking about is going and taking something that looks like this and determining what is the voltage, what is the current, voltage across and the current through each device. Okay? Best thing since sliced bread. No. Some people are going to really like this. Some people are going to be very efficient at it. Colton, you said you had tried this one. Your work is probably less detailed, and it's not to slam you at all, or anything like that. It's good? Okay. It's probably maybe not as much detail as I have here, but again, it's just the detail is something to be able to help you sort of keep sense of things. Okay? Were you able to get all the right answers? Yeah. Good for you. All right. So, folks, I'm going to stop there. Do you have any questions for me from the solution that you're like, oh, how did I do this, or what did I do there?
Great.
All right. What I'm going to have you guys do, it's 1:38. We have 7, 8, 9 minutes, somewhere in that area before we leave today. I want you guys to try to do the solution for number 1. I want to see number 1 as a solution before you guys go. I want you guys to try that. Now, you're not going to have space here, folks.
Oh.
You're not going to have space to do that work. So you're going to be stapling your worked out solution to this thing here when you go turn it. You're not going to have space on that sheet to do that work. This is not like doing series in parallel where you're just like, oh, it's very simple. You can do this one I want done on a separate sheet. And you can. Here's number 1. And your goal is to figure out all of these values. I total, R total, I1, I2, I3, I4, E1, E. All right, so that's your goal. Okay. Oh, no, it's just one. Just one circuit. Just one circuit. I want to see how you guys do on that. I think the other ones that I gave was I need to look at it. I need to look at it.
Yeah.
Just one.
So you want to,
Just one.
do your map?
All right, have at her. See what you can do. I apologize. Oh my gosh, stop sharing. Stop.